So this is a video related to our Google Meet that I'm going to do live with the class. Today is Wednesday the 27th. So for those of you absent, I was going to start by talking about this Graphing Stories page to see what answers people had gotten. This was my graph, how George ate his popcorn at a steady rate, stopped eating, continued eating. Alyssa gave him some popcorn, and then he continued eating. And then Alyssa, she didn't eat for a little while, started eating, realized George was running out, so she gave him some of hers, and then they continued eating and ended at the same time. So just what are some of my answers? I noticed the lines had the same starting and end points. I noticed they had a different slope. When Alyssa waited, I used a horizontal line because her popcorn would stay the same. When she gave him popcorn, I did a vertical line because it didn't take her any time, but her popcorn went away. And then how did I show they finished at the same time? This was my one that showed that. So they both had the same x-intercept. So they had 0 popcorn at the same time. And then I just am going to talk to the class about what answers they got for these problems on the back page. So these were my answers. So if you wanted to just compare them to your answers, I'm going to kind of go through my explanation, but see what answers the other students think would have matched. And I think the big takeaway is recognizing what is the dependent variable. Because if you're thinking about a different dependent variable, like I think A was about the roller coaster. If you're thinking about the height of the roller coaster, this map wouldn't match for the height of the roller coaster. They wanted the speed of the roller coaster. So the speed was steady at first, and then it got greater and greater as the roller coaster went down over the hill. So thinking about your dependent variable. I'm also going to talk to the class about the linear pre-assessment. And so what I did is I went through the where is it? I went through the linear pre-assessment, and I'm going to do some examples with them about the highly missed questions. So I was going to do a mini lesson today about just these few questions from the linear pre-assessment. So if you wanted to open that back up on your own screen, these are the questions related to reviewing slope, function notation, increasing, decreasing, and parallel perpendicular. So my 4 examples that I'm going to do with the class are, let's remember first how to find the slope off of a graph. So if I have, a few points like this, and let's say I start here, and my next point is here. How much did I rise? I rose 2. How much did I run? I ran 1. So the slope of this line is 2, or I could write it as 2 over 1. So finding slope from a graph is important. And that kind of ties in with increasing and decreasing. So increasing is always going to be a positive slope. As I read my graph, it's going up. And you always read a graph from left to right. Decreasing would have been going down. So for example, if I started here and ended here, just for a quick sketch of this, I just went down 4 and over 2. Down 4 and over 2 would have a slope of -2. That would be a decreasing line, a negative slope. Function notation, just remembering what this notation means. So for example, f of x equals 3x minus 2. That's a function. This is like saying y equals 3x minus 2. If I want you to find f of 5, all I want you to do is plug 5 in for x. So 3 times 5 is 15, minus 2 would be 13 as an answer. So function notation. And the last idea that I wanted to review today, which we are going to touch on these things more next week, but it never hurts to start planting those seeds. So parallel versus perpendicular. So for example, if you had y equals 3x plus 5 and you had y equals 3x minus 2, these lines have the same slope. So the same slope means that the lines are parallel to each other. We're going to talk more about slope-intercept form next class as a warm-up. I don't want to spend too much time today, but I just wanted to talk about parallel versus perpendicular slope because we're talking about slope right now. So perpendicular slopes, if my first line is the same, my second line has to be an opposite and a reciprocal slope. Opposite just means one is positive and one is negative, and reciprocal means I actually flip that 3 upside down and I make it 1/3. So for example, if you had a slope of -2/3, you would have to have +3/2 in order for those to be perpendicular slopes. And obviously, if it's not the same and it's not opposite reciprocal, it would have to be neither. So parallel, perpendicular, or neither. So then I'm going to do 6 warm-up questions with the class where they can practice those couple skills that we just talked about. And so these are the warm-up questions that wouldn't hurt for you to also go over kind of quickly here, or we could talk about them. So in this first one, if you were going to find f of 8, I want you to take a minute and calculate f of 8. Or pause the video while you're finding the answer. So write your answer down somewhere, and I'll show you the answers at the very end of this quick warm-up. There are 7 questions. So question number 2, here's another function notation. F of x equals -x plus 7. Find f of -3. So plug in -3 and write down your answer. Pause the video if this is going too fast, because I want you to actually try these warm-up questions on your own, and I'll show you the answers at the end. Find the slope between 2 points. Oh, I never reviewed that over here. Let me go back. So here was graphing and finding slope. I also wanted to review having 2 points. So like 5, 1 and 3, 7. So to find the slope between 2 points, maybe y2 minus y1 over x2 minus x1 rings a bell. This just means what is the change in y, so what's the rise, and what's the change in x, the run. For me, I always start with the second coordinate, and I just know that that's my y2 and my x2. Go in whichever order you want, as long as you're going to be consistent. So I would take 7 personally and subtract 1. 7 minus 1 on top in the numerator. Then I would take 3, because I started over here, 3, and I would subtract 5. So I get 6 in the numerator and -2 in the denominator, which reduces to a slope of -3, or you could write -3 over 1. Even though the negative is in the denominator, a positive divided by a negative is a negative. So you can just leave your answer as -3. So I'm going to do one like that on the warm-up as well. So here we go. Here are 2 practice problems that I'm going to show the class. So find the slope between 5, 4 and 6, 2, and also find the slope between 4, 0 and 4, 11. So take a minute and try examples 3 and 4 as a warm-up on another sheet of paper to write your answers down. And then number 5 is the function increasing or decreasing. And we were talking about the slope, right, being positive, so increasing. Would these lines be parallel, perpendicular, or neither? So you're going to put your answer down for number 6. I'm not going to say it this time. I gave it away on number 5. And number 7, find the slope of the line that would be perpendicular to y equals 1/4 x plus 7. All right, so if you haven't written down your answers yet, pause the video. I'm going to flip over my paper here, and you can just check your answers to those warm-up questions related to slope and function notation. We're going to do a similar warm-up tomorrow with some of the other missed questions from the linear pre-assessment. And then we're going to do kind of a fun warm-up word puzzles, but I'm not going to do that here because that's not a math-related concept that we're doing today. So then I'm going to take them on to 003, so the linear application problems. So I don't have another copy of this problem, and I want to keep this one blank for when I'm doing it with the class today. So I'm going to talk through it with you. May is growing a bean plant, and she forgot to chart the plant's height from the time it germinated, which means that the sprout is coming up. Below is the data she has collected so far. What is the slope of this line? So you can see that we've got some points that are plotted. So we just reviewed how to find the slope from a graph. It looks like I'm starting at 5 and I'm going to 8. So it looks like I'm rising 3 and I'm running 4. So the slope is 3/4, up 3 over 4. What does the slope represent in relation to this problem? 1b. So each day, right, each day, the plant is growing 3/4 of a centimeter. What is the y-intercept? Let's look at the graph. The y-intercept is at 5. What does that mean? So remember how it says she forgot to chart the plant's height from the time it germinated? The plant was already 5 centimeters tall, and then she started recording the data. So it was just the starting height of the plant. So that's 2, 5, and it's the starting height of the plant. Write an equation to fit this data. So if I'm asking them to do this today, I think what I'm going to do is also review slope-intercept form as part of our warm-up. So I'm glad I'm making this video because I realized that I probably should also do a review with them. I was going to save it for Thursday. I think I'm going to do it today. So a mini review of slope-intercept form. So I'm going to also go through and say, hey, if I have the equation 2x plus 8, just let's identify those pieces. 2 is the slope and 8 is the y-intercept. And if I have an equation that's written kind of in a different order, like what about 2x plus 3y equals 10? Well, I have to put it into slope-intercept form. So how would I do that? So I would subtract 2x to the other side first, so negative 2x plus 10. Then I would divide everything through by 3. So y equals negative 2/3 x, and then whatever 10/3 is. I'm just going to leave it as 10/3. What would that be? 3 1/3 if I wanted to make it a mixed number. And so in our in our question here about May's plant, writing an equation to fit the line, we said the slope was 3/4. So it's going to be y equals 3/4 x and then plus 5 because the y-intercept was 5. So y equals 3/4 x plus 5. So when we have that equation, y equals 3/4 x plus 5, they want you to say, on what day will the height be 17? So they want you to plug 17 in for the height and solve for the proper day. How would I solve this for x? So my first step would be to subtract 5 to the other side, and that would give me 12 over there. And then the second step would be to divide both sides by 3/4. So on your calculator, you could divide using parentheses. To me, it's easier to multiply by the reciprocal of fractions. So actually take 12 and multiply by 4/3. So what is 12 times 4/3? Well, 12 times 4 is 48, and 48 divided by 3 is 16. So the answer is 16. They wanted to know on what day would the height be 17. So it would be on day 16. What is the projected height of the plant after 45 days? So we would take our equation and plug in the number 45. So I would do 3/4 times 45 days plus 5. 38.75 centimeters is what I get. Do you think this is reasonable? Do you think that a plant could be 38 centimeters tall? I think so, right? I mean, a meter stick is 100 centimeters long, so not even a whole meter stick, and this is a bean plant. So do you think it's reasonable? I think so. What's a reasonable domain? So what that means is, do you think this plant is going to grow forever and ever and ever, like 300 days? The growing season in New Hampshire is what? Maybe 6 months if you're lucky. 6 times 30 is 180 days. So I don't know, maybe the growing cycle ends at 200 days for this plant or 250 days. I don't think it goes, 365 days, a whole year, unless it's a perennial plant, not in New Hampshire, right? Okay, so that was number 4. So number 5, this time I've already gone through an example with them. So what I might do is just sit back for a minute and have them try problem 2 and give them a little bit of time to do all of problem 2 on their own and then go through the answers with the class on the Google Meet. So the slope of the line, I go down 10 and over 10. So negative 10 divided by 10, the slope must be negative 1. What does that represent? The height of the candle is going down 1 inch every hour. The y-intercept, 10. What does that represent? Well, the original height of my candle, it was a 10-inch candle, right? And it slowly got shorter and shorter and shorter over time. Write an equation to fit this data. So my equation would be y equals negative 1x plus 10. And it says, what's a reasonable domain for this? Can this candle burn for 4 hours? Yep. Can it burn for 11 hours? Nope. The last time it's burning is at 10 hours, right? Because then there's no candle left. So the domain would go from 0 up to 10. And if you wanted to write that as an inequality, 0 is less than or equal to x, which is less than or equal to 10 hours. And problem number 3 is a scatter plot about an ice cream shop. They're keeping track of how much cold soda they sell and what the temperature is outside. So the general trend, does it look like it's increasing or decreasing? It looks like it's increasing to me, right? So drawing in a line of best fit is a line that kind of goes through the set of points, just kind of eyeball it. Where would that line of best fit go? About there maybe. And so it says, let's estimate the slope. To estimate the slope, you would choose 2 points that are roughly on that line. So let's just pick, let's see, what 2 points are we going to pick? I'm running out of paper. I kind of need a whiteboard here. So let's see, I don't know, this is the point, what, maybe 65, 170. Let's pick that as our first point. We got to pick something. And then let's pick something way up here. How about 85, I don't know, 184? Does that look like 85, 184? Sure, 85, 184. So let's solve by doing y2 minus y1 over x2 minus x1. So what's 184 minus 170? That'd be 14. And 85 minus 65 would be 20. So 7/10 is my slope. So y equals 7/10 x. And I think, see, here's a little problem. This scale counts by 65, 75. They really should have put a break in the graph. So this is a deceiving y-intercept. This is not really your y-intercept. This graph would go way down to here, right? Because this is not to scale. So to find out your y-intercept, here is a way to do that from Algebra 1. Pretend that you don't know your y-intercept. So y equals 7/10 x, that's the slope, plus b. You're going to plug in one of the points that you know. So I know that when y is 170, my line of best fit is at 65. We need to come up with a b value that will make this true, and that will be our y-intercept. I'm going to do 7/10 times 65. And I'm going to subtract that number to the other side. So 170 minus 45.5. So that's telling me that my y-intercept is actually at 124.5. Now you may have a different y-intercept if you picked a different set of points. So this is just a line of best fit we're looking for. So write an equation. So y equals, we said it was 7/10 x plus 124.5. There's my line of best fit. Now, it would be even better if we knew all these coordinates. We could plug them into our scatter plot and have the calculator do the line of best fit for us. But we would just be estimating those points. I don't know those points. All right, so now use your equation to estimate the number of cans sold when the temperature is 68. So go ahead and plug in 68 and see what you get. 68 times 7/10. So times 0.7 plus 124.5 comes out to 172, so about 172 cans. Does that seem reasonable? 68 degrees, yeah, 172 cans would fall right on our line. What's a reasonable domain? So domain is allowable temperature. Is the temperature ever going to get up to 120 degrees? Maybe, if you're in Arizona. Is it ever going to get down to negative 30 degrees? I don't know, 30 below. I mean, pick a reasonable domain for your ice cream shop. Maybe, 30 degrees, because you're going to close in the wintertime, 30 degrees up to 120 degrees if you're in Arizona, something like that. Reasonable domain, not an exact answer that they're looking for there. All right, so the last problem, here's a graph, and it's how far from your home you are. So you're riding your bike. So let's look at this graph together. Actually, why don't you take a few minutes first, see if you can answer 1 through 6, like I'm going to have the class do today. And I'll give them a couple minutes and then we'll go through the answers together. So I'm going to go through the answers now. The y-intercept would be 0, 0. How does the y-intercept relate to this problem? You're at your house. So at time 0, you're 0 meters from your house. Number 2, what's the slope of line segment A? I went up 100 and I ran 50. So 100 divided by 50, it has a slope of 2, right? 2 meters per second is the speed of the bike. Number 3, slope of B. I'm going down, how much? Down 60 and over 20. So negative 60 divided by 20 would be negative 3. So I'm biking at 3 meters per second. The negative slope means now I'm biking back towards my house. So maybe I leave, maybe I'm going to work. I realize I forgot something. So I turn around, I go back to my house faster. Then I didn't get quite back to my house. Maybe I found my cell phone in my pocket or something. So then what's the slope of C? I'm rising from 40 up to 160. So I'm rising 120 and I'm running 30. So 120 divided by 30 has a slope of 4. See how that's even steeper than these other two lines? And so that's the slope of C. What's the slope of D? 0, horizontal line. Explain how that relates to the problem. I probably got wherever I'm going. Like I got to work, and so now I'm just at work. So I'm not on my bike. I'm not moving further away from my house. And then on which line segment is the slope the steepest? C had the steepest slope. So once I go through that set of problems with them, the thing that they are doing today is 0, 0, 4 on their own. So it's a linear situation. So we just talked about exponential yesterday, and we're going to have them do some linear work today. So they're going to do a scatter plot. If you're not sure how to do the scatter plot on your own, here is the instructions for doing a regression problem. And so they're going to go through situation 1 and situation 2. And if they need help on converting Celsius to Fahrenheit, there's an equation down here. So you're going to plug in, I might do this part with them first. So this says the following equation can be used to convert Fahrenheit into Celsius. Solve the equation for F. To solve this equation for F, you would multiply the 9 to the other side, divide by 5, and add 32. So I'm going to probably give them this equation that Celsius 9/5 Celsius plus 32 will give you your Fahrenheit. So that way, when you plug in the number 31 right here, you're going to do 9 times 31. Let's do this on my calculator. So 9 times 31 divided by 5 plus 32 gives me 87.8 degrees. And I would just leave it in, the decimal, whatever decimal you get. They want you to fill in the Fahrenheit column, then use Fahrenheit as X and cricket chirps as Y. And you don't have to order these as long as whatever this is next to this in your table under Stat Edit. You should be able to complete that problem just fine. And I will also be attaching a linear review Kahoot onto the agenda for today. So if people finish early this linear situation, and they send it to me, they can do a practice Kahoot on some of those linear skills. People were asking for a review of their linear skills. Thanks. Hope that's helpful.